The goal of today's video is to learn how to graph y equals 2x squared minus 4 using the tactile graph. This is a parabolic equation, so we need to work with 4 quadrants here when we're constructing our graph. First, we got to outline the steps. We say step 1 is to construct the graph, step 2 is to find the intercepts, step 3 is to find and label coordinates, and step 4 is to draw the line. Now we begin the problem with that first step, and we construct this graph. As we're constructing the graph, it's important to think about what kind of scale we want to give our axes. You can see me kind of creating the graph and then going back and changing the scale of the axes to better fit our problem. So right now I have that scale on the x-axis such that each hole in the x-axis marks half of a number. So it starts at 0 and it goes to 0.5 and then to 1 and then to 1.5 and then to 2 and so on and so forth. However, on the y-axis, since that y-axis grows quicker, it's much more reasonable to use a scale that's larger. So in this scale, I've chose each dot, each hole, I guess, to just represent one increment. So it goes from 0 to 1 to 2 to 3 on each hole. It's kind of up to you how you want to graph that scale. But when you're constructing the graph, you might see that more coordinate points fit if you modify those scales, or maybe you just get a better picture. I chose this option because I wanted it to kind of fill up that whole graph and make a symmetric looking picture. Obviously, the parabola is symmetric, but this one is just symmetric and symmetric across the y and the x-axis due to that 2 in the front, that slope of the scale. You might find that it's actually easier to figure out the scale of your axis as you're determining the coordinate points. And so if you want to go that route and kind of flip those steps around, that's absolutely an option that you have. I actually tend to do that when I'm graphing too. So, you can see me writing out this scale initially, but I had already mapped it out with constructing the graph first. And so that was me working through the scale at the same time as the coordinates. And also I'm well versed in math, so don't feel threatened by the fact that you might not get it right the first time. I didn't get it right the first time, and I made the problem up. After you've constructed your base graph, you'll want to find the intercepts to be able to mark those coordinate points. So we start when y equals 0 and x equals 0. Starting off with y equals 0, we can see that if we plug in 0 into the y of that function, we get that 2x squared minus 4 equals 0, and that means that 2x squared equals 4, and then dividing out that 2, we get x squared equals 2, and then square rooting both sides, we get that x equals plus or minus the square root of 2. We'll also want to find the x-intercepts, and so that's when x equals 0. In this case, there's only 1, but when x equals 0, we just plug in 0 for x. We get y equals 2 times 0 to the power of 2 minus 4. And anything times 0 is 0, so we can just cross off that first term, and we know that y equals negative 4 when x equals 0. Since the x-intercepts are not aligned with one of the holes in our x-axis, we won't worry about marking that one out specifically. We'll just eyeball it when we come across these values on the axis as we graph. The square root of 2 is roughly 1.4, so we just kind of want it to be at the edge of one of our holes at that 1.5 marker. The next step is to find and label some coordinate points. Since we already have those zeros for the x and y intercepts, we can increment the x-axis by 1 unit. And in this case, we're going to go to both sides. So we're going to go from 0 to 1, and then we're also going to go from 0 to negative 1, 0 to 2, 0 to negative 2, that kind of thing, just so we get the full picture of our graph. Since it is parabolic, it's going to be on both sides. So when x equals 1, we know that y equals 2 times 1 to the power of 2 minus 4. 1 times 1 is still 1, and 2 times 1 is 2, and thus y equals 2 minus 4. So when x equals 1, we know that y equals negative 2. And conversely, when x equals negative 1, we know that y equals 2 times negative 1 to the power of 2 minus 4. A negative number times a negative number is a positive number, so negative 1 times negative 1 is 1. And then 2 times 1 is 2, minus 4 is negative 2. So when x equals negative 1, y also equals negative 2. And then we'll keep incrementing, so when x equals 2, y equals 2 times 2 to the power of 2 minus 4. Wow, that's a lot of 2's. So 2 times 2 is 4, 4 times 2 is 8, And so y equals 8 minus 4. And then so when x equals 2, y equals 4. And on the same side, since that negative number is squared, x equals -2, you get the same result. When x is -2, y is 4, just like the last one. Incrementing up to 3, when x equals 3, y equals 2 times 3 squared minus 4. 3 squared is 9. 9 times 2 is 18. 18 minus 4 is 14. So when x equals 3, y equals 14. And on the other side, when x equals -3, you get the same result, 14 for y. And since 14 is actually outside of the scope of our y-axis, we actually won't worry about graphing that coordinate specifically, either of those coordinates. And we're not going to increase the size of our y-axis. We could do that because y is infinitely long, theoretically, speaking. And this parabola could keep going forever. But I'm going to stop at my physical limit of when x equals 2. That's my last coordinate point. And we'll just know, denoting those little arrows, that this parabola goes on forever up. And then lastly, we just want to connect all of our coordinate points. As I have mentioned throughout this video, this is a parabola. And so those parabolas are shaped like a U. If you don't know that off the top of your head, I would just recommend going to Google Images and Googling x squared equations, because those numbers involved in x squared, that -4, just means we drop that U shape, that parabola shape down 4 on our y-axis, just like we've done. And then the 2 in front of the x squared, it just denotes kind of how skinny or fat that U is. So if it were much larger, like 16x squared, we'd see like a really skinny U, because it's just increasing really, really quickly. As x increases, y goes up really quickly. However, if it were like, I don't know, 0.25 times x squared, you'd see a really fat U. And so y would be increasing a lot slower than x would be. In our graph, because of the scale of those x and y axes, we're actually seeing that y and x increase at the same rate visually. However, numerically, they don't. Y increases twice as fast with that 2 in the front. But my y-axis is scaled at 2 times my x-axis. And so that's why we're seeing that this is a very beautiful U shape. It's very symmetric. They look like they grow at the same rate, but that, again, is just due to the scale of our axes. And so we should be really cautious not to assume that they all are going to look exactly like this perfect U. It really depends on those slopes in front of the x squared, the intercepts, whether or not they're up or down on our y-axis, and then additionally, if we've scaled our axes in a different manner, like I have here. If you liked this tutorial and you want to watch more tutorials with the tactile graph, I am intending to make more of these as I go along. So feel free to subscribe, and thank you so much for watching. And if you are interested in getting your own tactile graph at some point in the future, I will be bringing this to market sometime next year. So if you want to get more information on that process and stay in the loop, then feel free to subscribe to my newsletter going to tactiletutoring.com. Have a great day.